Hello everybody, my name is Professor Soborno and Bari from Bari Science Lab, and today we're going to be looking at temperature and kinetic theory. This highlighter actually works. So, today we're just going to be zooming in on the three types of matter, the three common types of matter at least. We're not going to talk about Bose-Einstein condensates or plasma or anything complicated like that. So let's say you have a solid. So if you have like a concrete block, when you zoom in, it's made up of many tiny particles and molecules. I just want to give the feeling or good drawing here. So molecules are just, parts of atoms. They're just bunches of atoms. How do you say this? Yeah, bunches of atoms. I think that's how you would want to say it. So, there's a bunch of kinds of molecules everywhere. They're made up of different kinds of atoms, and these molecules make up the basic building block for what we call solids. So, when in solids, you take these kinds of things, and they're really just bonded together very strongly. So they're bonded together very strongly. So you might have seen this representation of it. It's called a crystal lattice, apparently. And it basically shows all of the molecules just being in their place. They hardly move. So, this is basically how most people portray the crystal lattice. And they're right. Solids do hardly move. However, then how do we break solids? Like how I accidentally broke this lamp here once. How do we break solids, like this broken lamp? Well, when we push on solids with enough force, it kind of just breaks the bond between these molecules, screws them up, and the molecules individually are not getting out of there. The bonds of the molecules are being cut and split, and that causes everything to just break off. And sometimes when the cut is not that major and it doesn't crumble everything into pieces, like with this injured lamp over here, all of the molecules don't break off, but simply one huge chunk of the molecules decides to stray away from the rest because of the breaking force. So that's basically how it works. Now, however, liquids work in a different way. So let's say you have a glass of water. So I'm just trying to illustrate this in a nice way. So say you have a glass of water, and this glass of water is just filled with water. Of course, that's what it is. So now, what is the water made out of? Well, the water has molecules of H2O that freely float around in space. They don't actually freely flow around because most of them stick and jostle to each other, but they don't stick like really hard like solids do. Since there's a little more heat applied to them, they can jostle, wobble, things like that. I'm not going to do that dance for more than 5 seconds because it's going to make me look real bad. So, this is basically how liquids work. And then finally, gases. So, when you have gases, like carbon dioxide, the particles can move freely and expand wherever they want. So, they can move around in any direction they desire. And that's how gas just expands without losing too much density. All its particles just crowd away and just like get out. And it can not only mold into the shape of everything it touches, but it can also expand freely. Liquids only satisfies one of those conditions, and solids satisfy none. So that's basically how gases work. That's basically how solids, liquids, and gases work on the microscopic level. This is Soborno Bari from Bari Science Lab, and I'll see you guys next time. Bye!